So in the previous lecture, we have gone through about the linearization of the nonlinear model. Okay, so we have seen the example for the single variable, two variable, and it is for the generalized nonlinear models. And in the generalized nonlinear models, we have to, you have to find the Jacobian matrix for the linearization purpose. So as we already discussed, if the matrix, if the model is complex and the model is simultaneous nonlinear equation, like if suppose that the one of the examples, the multiple effect operator, where you model the multiple effect evaporator of the seven effect. Let's say there's a seven effect of evaporator, and when you're going to model them, so you find that there will be the 14 nonlinear equation having the 14 variable, right? 14 unknown variables. So your target is to find that 14 unknown variables so that you can predict the best, energy optimization parameters, right? So for that purpose, you have to solve that equation. So 14 nonlinear equation, 14 non variables are there. So you have to find out the, f del f1, del f1, you can see here. Wait a minute. Sorry. Del f1, you can say del f1 upon del x1. So it is go up to the, del f14 up to the del s14, right? तो इस तरीके से आपको f1 से लेकर f14 तक आपका इक्वेशन है, और वेरिएबल जो है x1 से लेकर x14 तक है, right? So amazing that how you have to determine this Jacobian matrix, okay, A and B. So it has become some difficult using this technique, right? So another technique to find out the solution of the such nonlinear equation are the, the optimization techniques, right? Optimization techniques by which you can determine. So there are so many motivated, you can say the nature inspired or nature motivated algorithms are there, like the swarm intelligence, right? And the physics based algorithm, right? You can say you have heard the name of the PSO, है ना? And particle swarm optimization, right? Neural network fuzzy logic. So there are so many, or Python techniques are there in order to solve such type of the nonlinear models, right? So that model, that is very easy to implement, and it gives the approximate solution near to the your real answer, right? So here you have the one cone type of the tank is here. This is a nonlinear, nonlinear in nature. So your target is to determine the model of this tank, right? So it is the assignment problem. Try to solve, try to solve at your home, because we have already seen, or you can also take the help of the Google and find out the model of the system, transfer function of the system ultimately, right? Okay, now we are coming to the next part, that is the mixing process. Okay, how the mixing process is going to model. Okay, so you can see here, let's say the Q is the flow rate of the input fluid or input flow, right? Xt is the concentration, and let's say there are some water or some liquor inside this tank present already. So this Xt concentration of the liquor is going to mix in from this with the help of some stirrer, right? The volume of the tank is a V, the concentration becomes Yt, and the output of this, the product having the concentration Yt with the flow rate Q, right? So what you will write the equation? So this is the problem of mixing. This is a problem of the salt concentration. So you can write here the flow rate of the salt in minus flow rate of the salt out equal to whatever the rate accumulated. So in minus out is equals to accumulation, right? So flow rate of salt in कैसे निकालेंगे? तो flow rate मतलब kg per meter cube और उनको meter cube per second, right? Volumetric flow rate. एंड दैट कंसंट्रेशन इज गोइंग टू मल्टीप्लाइड विद दिस. तो हम लोग को पता लग जाएगा कि इतने वॉल्यूमेट्रिक फ्लो रेट में कितना कंसंट्रेशन इन कर रहा है Similarly, you can find out what amount of the concentration is going to out with this volumetric flow rate. So Qx minus Qy is equals to what is going to the accumulation. Accumulation is also in the term of dy by dt. Dy by dt, because the concentration is ultimately going to the accumulated inside the tank. Okay. So you can write V dy by dt, right? Since V is the constant, okay, V is the constant, so you can write like this. Okay. So this is the point here. Okay, at a steady state, as you know that at the steady state becomes the constant. Okay, it becomes the constant Qxs, Qys, okay, and the d by dt of this yt becomes 0 at the steady state, because it holds up to the ys. Okay, so just to it represents this equation number 1, this represents equation number 2. 1 minus 2 है ना, q into x minus xs minus q y minus ys, right, is equals to d by dt. Sorry, take the common v, d by dt of y minus ys. Take the define the variable, the deviation variable. This is the x, this is the y, this is the y. Okay, and take the Laplace transform. So it becomes ys upon xs is equals to 1 upon tau s plus 1, where tau is equals to defined as a v by q. Any problem? Just to ask. You are free to ask. रिपीट करो दोबारा या समझ में आ गया? Please let me know. Is it clear? Is the voice audible?
Yes, sir. Please.
Yes, sir.
It is clear? So yes or no?
Yes, sir.
Okay.
Yes.
So now come to the next problem, that is the blending. If you require to revise this or to demonstrate once again, I can do, right? So don't hesitate to ask. You are free to ask, right? So next problem is the blending process, because such type of problem may be asked in your examination. So this is very important, right? So it is a simple problem. In the exam, some different types of the connection will be given and you have to model them. You have to find out the transfer function, right? So it is not very easy, right? So try to manage such type of problem, right? So blending process. Next example, the blending process. In the blending process, you can see here the first flow rate of W1 with concentration X1 is going to enter the tank. In similar way, the second fluid is with the flow rate of W2 with concentration X2 is going to enter in the tank, and in the tank we are going to mix them. We are going to mix them with the help of the stirrer, and the final product is the final product leaving by this tank with flow rate is W and the concentration is X, right? So you have to model, you have to find out the transfer function for this system, right? So how will you do? So please see, mass in, whatever the mass is going to in is equals to the mass out, right? So rate of mass in minus rate of mass out is equals to rate of accumulation. Simple. So what is going to the in mass? Mass in क्या हो रहा है? तो W1. मास इधर से क्या इन हो रहा है? W2. मास आउट क्या हो रहा है? W. एक्यूमुलेट क्या हो रहा है? यहाँ पे समथिंग, है ना? तो यहाँ पर हमने इसको W1 प्लस W2 माइनस W, W1 प्लस W2 माइनस W is equals to V dV by volume is going to change. So dV rho by dt. This is a mass. Simple. Volume into density is mass. Yes or no? तो यहाँ से आप इसको फाइंड आउट कर लीजिए. तो ये आपका बन गया kg per second, kg per second, kg per second और मीटर per second, मीटर per second. At the unsteady state, अगर आप इसको component balance में लिखेंगे, तो you have to multiply with the x, whatever their concentration is there. So W1 x1, W2 x2 minus Wx, right, is equals to d by dt of what? D by dt of v rho by x. Is it clear? Yes or no? D by dt of v rho x is equals to W1 x1 plus W2 x2 minus of Wx. It is written here. At the steady state, what will happen? At the steady state, this equation becomes W1 plus W2 minus W is equals to 0. And this equation becomes W1x1 plus W2x2 minus Wx equal to 0. So these two equations have been written based on their steady state value, right? So when you find out, when you minus this equation minus this equation, right? And sorry, this equation minus this equation and this equation minus this equation, then you will got the two different equation. So based on, yes, you can see here, based on that equation you can write the final equation like this. Okay, is it any problem? So this is the type of the blending process, right? Okay, next is the heating process, and it is most important. Here the most important problem, because these are the simply mass and mass and component balance. These are the mass and component balance. Now what we are going to discuss is the energy transfer, and energy transfer becomes very important, right? So we have heating process है, तो heating process में पहले आप ये बताओ कि heating process में क्या transfer होगा? What is the transfer?
Energy.
Right? So
Energy.
in the energy, right, you are right. Very. In the energy, what is the unit of the energy? Please tell me. Joule. Very good. Joule. So अब जो आपका एनर्जी ट्रांसफर होगा वो क्या होगा? क्या होगा बेटा? जूल मतलब एनर्जी पर टाइम, पर सेकेंड या आर वॉट एवर. तो हम इसको यहाँ पे जूल पर सेकेंड में डिफाइन करें या जूल पर आर में डिफाइन करें या किलो जूल पर आर में डिफाइन करें, एनर्जी पर टाइम होगा. कुल मिला के बात ये. यस सुनो.
Yes.
Okay. So see here the problem. ध्यान से देखना. W is the flow rate, volumetric flow rate, right? Time Ti is the temperature, whatever the temperature of the fluid that is going to enter in the tank, and some steam, some heating, some heating, you can say the fluid, heating liquid is going to enter in this tank with the help of, it may be the steam or it may be the, the heating is going to done with the help of the electricity, coil. Yes or no? So you can do with the help of the steam. Generally in the industry we have already discussed the steam is used to in order to heat something, right? Okay, and W and T is the product flow rate with the temperature T. It is clear? So now what is going to be, we have to write the equation. We have to write the equation. So आप बताएं जरा राइट कैसे, इसको इक्वेशन लिखने के लिए क्या किया जाएगा? Anyone? What is W? What is W? W is the, बोलो भाई, W is the, W क्या है? W is the flow rate. Yes or no? W
Yes,
is the
sir.
flow rate,
Yes.
right? What is C? C is the specific heat. C is the specific heat. What is T? T is the temperature. Good. T is the temperature. ठीक है. अब आपको क्या करना है? What is the unit? Just to manage the unit so that you can understand, right? So you know that the T is in the degree Celsius. W is taken in the kg per hour. Volume, mass per unit, time. Whatever the mass is unit, mass is entering inside the, it may be the volumetric, it may be the in this. So दोनों हो सकता है. तो हमने यहाँ पे लिया है mass per time, right? Density is defined, sorry, density, ये क्या हो गया? Okay, density is defined rho, that is the mass per unit volume, right? Density is mass per unit volume. Volume is defined in terms of meter cube, right? Last term है एक हमारा specific heat, that is C, and C is taken in the form of joule per kg into degree Celsius. ये होता है कि नहीं होता? यस और नो, यस और नो?
Yes.
तो अब
Yes.
आप जरा इसको इक्वेशन को आप बैलेंस करने की ट्राई कीजिए. व्हाट यू विल गॉट, टेल मी व्हाट यू विल गॉट, what you will got. So W is kg per R, C is the joule per kg degree Celsius. Ti minus, why we have taken the Ti minus T reference, I will tell you, but the ultimately it's the degree Celsius. So degree Celsius will cancel to each other, kg will cancel to each other, it will come to the joule per R. So this is the energy transfer, yes or no?
Yes, sir.
So this
Yes,
is
sir.
the energy transfer ultimately joule per hour. Similarly, this is also the joule per hour. And what is this Q? Q is the heat supplied to the tank. Heat supplied to the tank. So it is again the joule per hour. Now come to this point. And what is the holding inside the tank? Ultimately, this is the what is going to at the end. The temperature is going to rise. Yes or no? Ultimately,
Yes, sir.
temperature is going to rise with the help of this heating material or heating something. Okay, so the accumulation is changing in the time in the temperature. Therefore, we have written dt by dt by t, right? And when you multiply with the rho Vc, it will again it comes the joule per hour. So when you multiply, it will come joule per hour. Okay, so आपको ये समझ में आ गया कि इन ये हो रहा है, आउट ये हो रहा है, कम ये ऐड हो रहा है. सो इन प्लस ऐड minus out is equal to some accumulation. Now the problem is why we have taken Ti minus T reference or T minus T reference. Okay. Okay. So the answer of this question is, anyone want to give the answer of this question?
सर क्योंकि जो सराउंडिंग का टेम्परेचर होगा वो तो कुछ होगा, वो तो जीरो होगा नहीं.
Yes. Yes.
क्योंकि हम डिफरेंस
Because we are going to increase the temperature from the certain value, right? From the, suppose that 27 degrees Celsius is the fluid what we are going to enter, and from that value this temperature is going to increase. Okay, so that reference and that initial value we have taken, the temperature of the surrounding is not zero and it is true, so therefore we have T reference we have taken. Okay, so solve this at the steady state, what will happen, this becomes zero, right? So WC, and then just to because just to minus the both the equation, this equation minus this equation. Okay, so you will got WCTI minus TIS. Okay, WC minus TS, right? And then uh, Q minus QS is equals to rho VC D T minus TS. What is TS? TS is the steady state temperature, right? Steady state temperature, right? तो इस तरीके से हमने इसको इक्वेशन को सॉल्व कर लिया माइनस करके. ओके, टेक द लाप्लास ट्रांसफॉर्म, डिफाइन द यू नो द डेरिवेशन वेरिएबल ti minus ts t minus ts. ओके, सो उस तरीके से क्या हो जाएगा आपका, फिर टेक द लाप्लास ट्रांसफॉर्म एंड देन the transfer function will come as a k upon tau s plus 1, where k is equals to 1 upon wc and tau is equals to rho v upon w. K is equals to 1 upon wc and tau is equals to rho v upon w. So this will come in the last, and this is the standard transfer function, again is the first order system. So ultimately you got that, you conclude that the single tank system in anyhow it will yield the first order system, only. Okay, no way to find the first order system to second order, it is the first order system only, right? So whatever you have seen, these are the example of the lumped parametric model. Now we are going to see the distributed parametric model. Distributed parametric model, right? So I'm trying to make this video